Okay, we have our Taylor integral. This one's from the MIT integration, be 2013, problem 24. We have here the integral from minus pi over 4 to pi over 4 of 1 over 1 minus sine x dx. Okay, the first thing I noticed with this problem is just the bounds is kind of different, that we're going from minus pi over 4 to pi over 4. The nice thing about this is we don't have to really worry about pi over 2, sine of pi over 2, end up dividing by 0. But with these bounds here, we really have no issue. So what I'm going to do, so to get started, what I want to do with this, I'm just going to multiply by 1. I'll rationalize this by multiplying by 1 plus sine x over 1 plus sine x. And again, there's no problem with this because we don't have minus pi over 2, so there's no divide by 0 issue here either. So then multiplying this out, we'll keep the bounds. Then the numerator is going to just become 1 plus sine x dx. Then when we distribute this out, we're going to get 1 minus sine squared x. But 1 minus sine squared x, I can write that as cosine squared x. But then what I can do is just divide the cosine squared x into each term. So let's see how this is going to look. When I divide cosine squared into 1, we just get for our first integral secant squared x. And then for the second term, when we divide cosine squared x into sine x, I can actually write this as tan x times secant x. And then here now we have two easy integrals, but I'm actually going to do something first. Just notice secant squared x, this is actually an even function. So what I can do is use this principle, allows me to update my bounds and multiply by 2 out front. But then over here, tan is an odd function and secant's an even function. So this whole thing actually is odd. But then we have the principle because we have an odd function and our bounds are symmetric around 0. We can say this whole integral is just going off to 0. So then we'll just go ahead and integrate this integral of secant squared. This is just going to give me tan of x, and we just need to evaluate from 0 to pi over 4. Evaluating this, I'll bring a 2 out front. Tan at pi over 4 is just 1. Tan at 0 is just 0. So when we multiply 2 times 1, we get our final solution of just 2. Okay, so there you have it, kind of a quick problem from MIT 2013. Thanks everyone for watching. Have a good day.